Hi friends, let us prove two important results. That is, in a circumcircle. Circumcircle is the circle that passes through the vertices of the triangle. Right, this is a circumcircle. Right, the circumradius is obviously the center of the circle, the radius of the circle. Circumradius is equal to A into B into C, that is the length of sides of the triangle, by 4 into area of the triangle. Area of whatever is the triangle. We have to prove this important result. This result is very important. At the same time, we also want to prove that area of a triangle ABC is given by BC into sine A by 2 or AB into sine C by 2 or AC into sine B by 2. Let us prove this two important results. First, let us try to prove the area result. Right. What is area of triangle? Area of triangle, we know half into base into height. Half into base into height. This we know by default, right? Let's take this as height h and this as base. Right. Now this angle is angle A. Right. If this is height means obviously this is perpendicular to this base. Right. We are taking height. Height is always height by definition. Height means this line is perpendicular to this base C, AB, right? So this is equal to, let's call this as height. What is B? Half into C into H. This is the area of this triangle ABC, right? Now, what is sine A? Sine A is opposite side by hypotenuse, H by B. H by B. This implies what is H? H is equal to B sine A. Right. Let's substitute this H here. So instead of H, let's write B sine A. That is our formula. That is what we wanted to prove. Half into BC sine A. That is this. Half into BC sine A. Similarly, we can draw perpendiculars to other sides. And using the same methodology, we can say half into AB sine C or half into AC sine B. Right. The perpendicular drawn onto that side. Right. Half into BC sine A. Perpendicular drawn. By using this perpendicular drawn, we are able to prove this formula. Half BC sine A. We can use the same perpendicular. You can use another perpendicular to the other sides and can prove the remaining two also. Right. Now this part is done. Proving area is done. Now how do we prove what is the radius of the circle? And how is this related to this length and the area of this triangle? Right. Now let's do this again. Let us call this point O as the center of the circle. Right. So that means O to C and O to B and O to A. These are all radii. They will be same. So this is equal to this. Right. This is equal to this. If you draw one more line, that is also equal to that. What does that mean? In this triangle OBC, angles opposite to equal sides are equal. Right. This angle is equal to this angle. Right. Let us draw a perpendicular from this point to this. When we draw this perpendicular, let's look at these two triangles, CO, and if we call this point D, COD and BOD. These two are similar triangles. Why? Because this side is equal to this side. These two angles are right angles, and this side is actually common. So, right angle triangle, hypotenuse is same. One of the sides is also same. Two sides are also same. So, obviously, these two triangles are similar. What does that mean? This angle is also equal to these two. This angle is equal to this angle. this angle is equal to this angle, this is 90, that means this is also equal to this. Right? These two angles are same. Now let's look at this arc BC. BC. This arc is making this angle at the center, whatever this angle. Right? The angle is COB. Let's say. Now this arc is making this angle A on the circumference, obviously. So what does that mean? COB is equal to 2 into CAB. Right? Angle at the center is double that of angle in the circumference. We already proved it. We have already proved in one of those other videos. Please go through that to find that this angle is actually double of this angle. Right. Now this angle is divided into two equal angles. Right. What does that mean? If this is A and this is 2A, at the same time this and this are equal, that means this is another A, this is another A. Right. Let us just simplify the diagram once again. So far we have proved if we draw a perpendicular, then this is actually A and this also equal to A, and this is the radius R and this is radius R. Right. Now what is this one? What is this one? This one, what is sine A? Sine A is equal to CD by R. Right. Let us do some small one manipulation here. Sine A equal to CD by R. That means R equal to CD by sine A. What is CD? CD is again this and this are equal. CD is A by 2. Right, equal to A by 2 sine A. Right. Now in the earlier formula we have proved area. This one we have proved, right? We have already proved earlier. From this, let's use the first part, which is sine A equal to 2 into area by BC. Right. This into this by BC. Let's replace the sine A with this, which becomes A by 2 into 2 area by BC. Right. This BC will go to the top, which becomes ABC by 2 into 2, 4 area. This is what we wanted to prove, and which is this. Right. It's simple algebraic manipulations. We just need to understand that the radii are same, and that's why we are able to find out this one in terms of sine A. Right. And then first we have proved what is the area and area in terms of sine A, and then the radius we used the formula of this area to calculate what is the radius, replacing sine A with replacing the sine A with radius equal to A by 2 sine A, and sine A we replaced with this uh, 2 into area by BC, and we are able to find out that ABC by 4 into total area is the circumradius. This is very simple algebraic manipulation, but still we should understand the proof. We should know the proof. Thank you, guys.